Okay, good morning. This is the explanation of the section 1 and 2 of Unit 5. The periodic table is a way to arrange elements by their increasing atomic number. An element is a substance made of just one kind of atom. So in the periodic table, we have all types of atoms arranged by their increasing atomic number. I remind you that the atomic number represented by Z equals the number of protons in the nucleus. For example, if we have hydrogen with atomic number of 1, means that hydrogen has just 1 proton in its nucleus. Iron, 26 protons in its nucleus, etc. There are 118 elements in the periodic table. 92 of them can be found in nature. The rest are made in the laboratory by scientists. The elements are also arranged in rows and columns. As you know, atoms have their protons in the nucleus and the electrons in the shell. The important thing is that the electrons in the shell are placed around the nucleus in certain energy levels. The distribution of electrons in the shell is what defines the elements that are in a row or in a column. The horizontal rows are called periods. All the elements in a row have their electrons placed in similar energy levels. For example, elements of the first period, which are hydrogen and helium, have their electrons in one level. Elements in the second period have their electrons in 2 levels. The third period in 3 levels, and so on. The vertical columns are called also groups. All the elements in the same group have the same properties because they have the same number of electrons in their outer shell. It means that they have the same number of electrons in the last level of energy. Each group has a different name: alkali, alkaline earth metals. Then we have a group of transition elements or transition metals. Then we have the boron group, carbon group, nitrogen group, oxygen group, then the halogens and noble gases. The noble gases, are very, very stable because they have their outer shell full of electrons. They don't react with any other element. Apart from rows and columns, we divide the periodic table, the elements of the periodic table, into groups: metal and non-metals. Metals are in the left hand of the table and non-metals in the right hand. In your book, you have a red line here which divides metals from non-metals. The elements next to this red line are called semimetals or metalloids. Why do atoms bond? Not all the elements are stable. In fact, just the noble gases are, because atoms are stable when they have their outer shell complete of electrons. For that reason, atoms of different elements join together with other atoms seeking for stability. They get that stability exchanging electrons. This joining is called bonding. When atoms bond together, they can construct mainly two types of structures. One of them are molecules and the other are crystals. Molecules are made of a small fixed number of atoms. For example, water. We have 2 hydrogen atoms and 1 oxygen atom. So one molecule of water is something like this. When we have a lot of molecules, they are individual groups of atoms. Okay? Something like that. Imagine salt. No, salt doesn't make molecules, sorry. Ammonium. Where we have, for example, in this case, one nitrogen atom and 3 hydrogen atoms. Okay? So these are molecules. Salt. Salt make crystal. How is a crystal of salt? We have 2 types of atom, but they are not individually arranged. They are repeated in a regular pattern. They are ordered in space. It's something like this. Imagine that this is sodium and chlorine. So we have sodium chlorine in 3 directions, not just one line. Okay, and imagine in the back of this atom you will have another of chlorine, another of sodium. So this is a crystal. Okay, so aggregates, agregados of a small number of atoms, aggregates of a large variable number of atoms.